Welcome to Summarize Science. Today, we are looking at a fascinating paper about bringing powerful AI directly onto your smartphone without needing an internet connection. Most of us use AI tools like ChatGPT that live on giant servers in the cloud, but this research explores how to make small language models work entirely offline on an Android device. The researchers used a word-guessing game called Palabrita to test these models in a real-world scenario. The goal was a fully private experience where no data ever leaves the user's phone. They initially wanted the AI to generate everything for the game: the word, its category, and 5 progressive hints to help the player. However, the study quickly discovered that putting AI on a phone comes with some surprising engineering hurdles. One major issue was that these small models often struggle with basic logic, like counting how many letters are in a word. For example, if the system asked for a 5-letter word, the AI might confidently provide a 7-letter word instead, breaking the game's rules. They also found that the AI's output would sometimes get messy, including weird code fences or translating labels into the wrong language. These output format violations meant the phone software couldn't understand the AI's response without a lot of extra help. Over a 5-day development sprint, the researchers had to radically transform how the AI was used. Instead of creating the whole puzzle from scratch, the AI's job was eventually narrowed down to just writing short hints for words already chosen from a pre-made list. This led to the core discovery of the paper: when it comes to on-device AI, less is more. By reducing the AI's responsibility, they moved from a system that failed constantly to one that was highly reliable. To fix these errors, they built a defensive system that could clean up messy AI text and try again if the first result was bad. The study also found that giving the AI concrete examples, like a word like estufa has 6 letters, worked much better than just giving it abstract rules. This type of prompt hardening was essential to make the small model behave. Another interesting finding was that these small models have a very short memory. They often start to give repetitive or boring answers after just a few turns because their internal cache fills up. To solve this, the researchers implemented session rotation, which essentially refreshes the AI's brain every few puzzles to keep the hints creative. The researchers distilled their experience into 8 actionable heuristics for other developers. One key lesson was to always provide a deterministic fallback, which is a pre-written hint the game can show if the AI fails completely. This ensures the game remains playable and the user never sees a broken screen. To recap, the paper highlights that while mobile AI is powerful, it is a fundamentally different tool than cloud AI. It requires accepting that the most reliable local AI feature is often the one where the AI does the least work. This matters because on-device AI is a massive win for privacy, as your personal data never has to be sent to a company server. It also means apps can run without an internet connection and without the high costs of cloud subscriptions. Looking forward, this research paves the way for a future where our devices are both smarter and more secure. If you enjoyed this look into the future of mobile tech, make sure to like and subscribe to Summarize Science for more.